Can you hear me? Okay. Okay. Should we wait a bit more until I see people coming in, or should we just begin? Okay. Welcome and good morning, everyone. Thank you all for coming here, both to this talk and to the beautiful city of Vienna. Today, I will show you how to augment your mobile app experiences with Snapdragon Spaces. I am Tsvetelin Dimitrov of Qualcomm, and I've been working for a little over 2 years on the Snapdragon Spaces Unity SDK. And although we are in the technical or developer and creator track, this is not really a hands-on workshop, but we will go into some technical details about Unity. So it is expected that you have some knowledge of Unity, for example, how the editor layout works or how the cameras are working. But if you don't know, that's perfectly fine. I will walk you through everything as well. So this talk is structured into 3 main parts. The first part, I will discuss about the developer and user problems in head-worn AR development. Then I will talk a bit about our solution to these said problems. And lastly, I will show you some examples of how to integrate the solution to enhance your mobile app experiences. Before we begin, though, I would like to talk a bit more about Qualcomm. As you may know, Qualcomm is the world's leading wireless technology innovator, creating both the hardware and the software that are used inside many of the world's mobile computing devices. Inventing the technologies and enabling a world where everything and everybody can be intelligently connected. Something that you might not be familiar with, however, is that Qualcomm has a presence in Europe under the name of XR Labs Europe, with offices in Amsterdam, Bordeaux, Madrid, Salzburg, and also right here in Vienna. Now, while Qualcomm is known for the silicon, we are also known for giving birth to excellent world-class research and development organizations, such as XR Labs Europe. At these organizations, we enable the full potential of our chips, and we have teams working on things such as simultaneous localization and mapping, also known as SLAM, image tracking, plane detection, and hand tracking, and also teams like mine, which are working on integrating all of these features into your favorite game engines and delivering Snapdragon Spaces to you, the developers and creators. Now, this is just a small part of what we do at XR Labs Europe. And if you're interested or have more questions, my team and I will be here for the rest of the day. So feel free to approach us. We have Snapdragon Spaces all over us, so it will be easy to recognize. And now to the main part. A lot of people have asked throughout the past couple of years what Snapdragon Spaces is and why we should be using Snapdragon Spaces. But no one has yet really asked, how is Snapdragon Spaces? Now, before we answer the how, we will answer first the what and why. Snapdragon Spaces was first introduced at the AWE USA conference in 2021, and it is an XR developer platform that enables developers to both tap into the uniform set of AR features that are designed to be independent of device manufacturers. Now, we are using OpenXR, which is a royalty-free open standard for XR platforms, across our perception stack. And we're also leveraging the power of the Unity and Unreal game engines to deliver and allow developers to continue using their comfort tools. Now, as it helps developers, it is also helping the original equipment manufacturers, also known as OEMs, by giving them the option to use Snapdragon Spaces platform to reach the group of already existing developers without having the need to create their own SDKs. Now, why would you use Snapdragon Spaces, you may ask? Well, we are a developer-first platform, which means that your developer feedback is very important, and it can help influence the development of our platform features so that together we can help make your visions come true. So how does Snapdragon Spaces seem to you? Our mission is clear, but there are still some issues that need to be addressed. I call them the pain points of head-worn AR. And as a developer myself, I have noticed that there has been a gap between mobile and headworn AR, and this gap is driving both developers and users away from it. Now, in order to understand what Snapdragon Spaces is bringing differently to the table, you would need to first understand what the current situation is. There are three main culprits that are driving these users away. The first one being complicated interactions. Now, I will not ask you to raise your hands if you've ever had to experience some complicated or unfamiliar interactions, because I know most of you must have. But this is something that is so simple to the user experience, yet a lot of developers are still getting wrong, and it could be due to the fact that there are still no established or standardized AR inputs. The second point is for those of you who are not only users, but also creators, and it is the long and iterative cycles of development. I'm pretty sure you're familiar with the cycle of having to change some value, build your application, start it on your headset, and then just notice that your AR content is completely off, or you forgot to check some boolean that you were using in your development builds on your editor. And I cannot tell you how many times I have spent drinking coffee while waiting for my build to finish. Now, lastly, the final pain point is that there's just a lot of SDKs already out there. And it is very complicated and cumbersome to constantly have to relearn new things, have to read through a lot of documentation to figure out how do you set up the scene, why is my input not working, or why did it suddenly stop rendering. And these are the three main points, but not all is lost, because we have dual render fusion. It is a feature in the Snapdragon Spaces SDK toolkit that aims to solve the pain points of headworn AR development. Now, it does so by enabling a full-featured mobile touchscreen input, which means no more companion controllers that look the same for every application, which is something that Snapdragon Spaces SDK is also guilty of. But instead, it allows us to use Unity's UI toolkit. So this means that no more external tools and no extra learning curve if you are already familiar with Unity. You are already building upon an established pattern. Secondly, it also does dual display rendering to both your mobile and head-worn display. And all of this is done within the editor just by adding an extra camera. We can see how this is already more flexible, and that this feature is more flexible than other traditional methods in AR rendering, where you just have a single output. We will get to that later. Lastly, dual render fusion gives the ability to extend your existing applications with AR as a feature. Now, this is useful for apps that were not designed for AR from the ground up, but instead, later down the development roadmap, it was decided that AR would be useful to enhance some particular part of the application. And I know what you may be already thinking. This is yet another SDK that you would have to learn. And this is the best part. It is extremely simple to integrate, and it is very easy to use. And developers are already using it. Now, first of all, dual render fusion does not redefine the way we do user experience, but contrary to that, it is quite the opposite. We're bringing back the same inputs we're already familiar with. And we're also empowering developers with more control over their own applications and the ability to use the full touchscreen of your mobile devices. Take Solitaire, for example. You can play using the touchscreen, but adding AR does not change the gameplay in any way, does not change the user interactions in any way, but only adds a layer to provide perception features to work and bring to the immersion of the experience. Now, this might look like a step back in headworn AR, but it is actually a step forward, because this is something that we have skipped over the development of headworn AR. And until all-in-one devices are available, we need a solid foundation to build upon, and this might be it. Now, here is where we'll get a bit more technical, but bear with me. So Unity is originally a general purpose game engine, and it is built for making games and not AR experiences. This was something that was later added on. Now, conceptually, there will be differences between how Unity does things and how we would like to do things in AR. One of those things are the single main camera. Now, in traditional video games, we would usually use a single camera to display to a single screen and not have a second external monitor that we're displaying to. Usually, the games will be played only on one monitor. But for AR, we would have two different screens. One is your mobile phone, and the other one is your headset. So this is something that Unity has already done wrong. So traditionally, everything was also designed around this. We either render on the mobile phone, or we either render on the headset. And this would leave the phone empty, which is where the need for universal companion controllers. Now, however, dual render fusion unlocks both screens to render the same screen or the same scene from two different perspectives. If you look at the component on the right, this is the camera component in Unity. And what it does is it basically has it's a view into the scene, into the virtual content of your experience. And dual render fusion allows us to have two cameras active at the same time, one having a target display of display 1, which is your mobile device, and the second one having a target display of 2, which is your headset. And now, with dual render fusion, you could have dual display rendering. If you're not familiar with the Unity user interface, first of all, this is a project that I will show a demo of, how easy it is to integrate Fusion into already existing projects and how easy it is to set up your scene. But yeah, if you're not familiar with Unity, we'll quickly go around what you should be looking for. So on the top right corner, there is the game view, which is set to display 1. I hope it's visible. This will show you what the mobile phone will see. On the bottom right corner, where it says no cameras rendering, is the game view of what your headset will see. And since there's no cameras rendering, it means that it's currently not set up. On the bottom left, we will have two things that show up. One is the feature list, which is the place where we enable Fusion from. And two is the OpenXR validator, which is a very nifty piece of software that allows us to fix any complaints that OpenXR has for us, such as there's no second camera. So I will quickly show you the video. We are opening a scene with a car that just has basic inputs for driving the car. Here we're enabling Fusion, and we can already see that it's complaining that it's not set up properly. We start fixing, and you will slowly see that there's a camera that pops into place, and there's other parts that are essential for AR usage. And it is just as easy as that. This was not recorded from inside the editor, but it was actually built on glasses and recorded. So yeah, it is just as easy as clicking a few buttons. There's no code required whatsoever. And just to show you how easy it is to update existing scene, here's another example of a different scene, but this time with a plane, where, again, we just click a few buttons, and we already have everything working. And if you want to understand more of what's happening, you can also still look at the code and realize where things are going and why things are happening, because everything is pretty well described, and it's very verbose. Now, assuming you're familiar with Unity's UI toolkit, you could already begin creating and tweaking your UI without even having to build your application. It is similar to how you would develop any other application. You can even use the in-editor hand tracking tools to mimic that experience as well. And when you finally decide to build your application, you can see that the UI translates seamlessly to the mobile phone, and your experience is identical to how it was in the editor. If you think that this is too good to be true, then here's a short video of the Snapdragon Spaces developers talking about dual render fusion.
that brings 3D maps to life in your glasses, while your phone screen becomes your control panel.
For our game Table Trenches, it was really easy to take our existing mobile UI and use that as our on-screen UI for Fusion, while in the headset, you can see the immersive gameplay.
It's been amazing to see this experience in augmented reality and to have an extra interface to use that everyone understands how to interact with. The addition of a smartphone into the experience allowed us to enhance the museum, so we chose to use it kind of like a pamphlet or guidebook in a real museum.
Ocean Cleaner shows how beautiful but fragile nature is. It lets you dive and remove trash from a coral reef. The combination of hand tracking and intuitive physical touchscreen deliver an incredibly realistic experience.
Now, to summarize this whole presentation, first of all, we all hopefully have noticed that there is a gap between mobile and head-worn AR development. And it mainly stems from the three pain points, which are complicated interactions, long and tedious iterative cycles, and just the plethora of different SDKs that in the end achieve the same result. Here at Qualcomm, we have unlocked the full potential of the mobile touchscreen with dual render fusion, helping us bridge this gap in XR development. You can already download and use the Snapdragon Spaces SDK at spaces.qualcomm.com, and also join our Discord community, which you can find a link at the same website. And we cannot wait to see what you will build with Snapdragon Spaces. Thank you very much.
Thank you very much, Tsvetelin. So I think it's great to see how easy it got to port an experience and all the step forwards that is made by Snapdragon Spaces. Are there, in the meantime, questions in the room? Please.
Thanks for the talk. It was really nice, and I really enjoyed using Snapdragon Spaces. Maybe the wrong question to ask to you guys, but will other manufacturers of chips like MediaTek be able to work with Snapdragon Spaces in the future?
So for now, I'd say that having Snapdragon Spaces and Snapdragon processors at the heart of everything in order to achieve the highest possible performance is what will be driving this forward. But as you already said, we're the wrong people to be talking about that in detail.
Okay, thank you.
Another question here in front. Thank you very much for being.
Hello, my question is, let's say I use your SDK as a mobile developer to augment my application, to have also XR experiences. But then let's say my mobile game is also on desktop, the same Unity game. Will my desktop game will also be able to use those same XR experiences?
Well, since this is running on our perception stack, we are using the Snapdragon the Spaces services, which is an application only for mobile. This will currently not work on desktop, so the perception features will not work on desktop. But yeah, I mean, this is what we provide. We provide XR for mobile, so there will be nothing on desktop for now.
Maybe a quick follow-up question. As far as I know, Snapdragon is soon going to be developing desktop computers, maybe Android-based, maybe Windows-based. Is it Android only, or are you also considering other operating systems?
For now, it is just Android. There has been no considerations, at least that I'm aware of.
Thank you.
We do have another question, so let's go there in the middle. Then after this, one more, and I think we have to wrap up.
Thank you for a really interesting talk. So if you expect me to use my phone as the controller for my AR glasses, how do you do that with pass-through? Like, to my knowledge, there's still, even Quest 3 has trouble doing good pass-through, seeing details on my phone. It's only Vision Pro that can really do that today. So how does that work?
So this is for a special hardware setup. Currently, we have a dev kit using a Motorola Edge 30 Pro and Lenovo A3, Think Reality A3. And this isn't targeting video see-through, but optical see-through devices.
Yeah, optical.
Yeah.
Thank you. So my more than a question is a suggestion. Very interesting, the usage of touch screen in order to solve the many interaction problems. But pay attention, because this is not absolutely true. Paul is going to use AR headset in field, meaning operators in field, for instance, from utilities. Over there, the fact to work hands-free, it's the main element that can justify the return of investment of the devices. If I say to the field workers, okay, now you have to extract your smart glass to interact, it's not worth it.
Yeah, this is a great point. But again, this is just an extension. So you could still have your perception stack working hands-free. You can even turn the screen off and it will still be working. But if you want this extra layer of user interface and user experience, you can provide it now to your users.
Yes, it was just say, go on your brilliant work with augmented interfaces that can work. So, thanks.
Thank you.
I think we do have time for one more question. I do have maybe one more is, so one of the also core design challenges when designing for AR glasses is the limited field of view that we currently have. Are there some of those things also like taken into account in the system? Like how can people start designing for different field of view for different AR glasses? Is that something possible?
You want to take that? That's a hard question.
Yeah. Currently, we are only supporting for the A3 glasses, the A3 AR glasses. But with newer headsets that are coming out and being available, we are hoping that this dual render fusion will fix this issue that if your field of view is limited, you can actually use the extended mobile screen to solve this.
Okay. Thank you very much, Guy. Let's give a thank you to Tsvetelin for the great work.